Great, so welcome back to Grade 8 Math. We're now starting Chapter 10, and this is 10.1. And Chapter 10 is all about geometry, and so this first kind of lesson is talking about the center of 3 points. This is really, if we look it up online, this is called the circumcenter. And what this means is this: if I give you 3 points, if I give you 3 points in space, I want to find the center of all 3 of these points. Well, what does that mean? Well, what that means is I can find a shape that connects through all these points, and that's probably a triangle. But I can just connect the 3, but what's the center of a triangle? Well, we know the center of another shape, and that's a circle. So what we can do is we can find a circle that connects through these 3 points. So if I put a circle here and I move this along, well, this connects through A and B, and I can find the center through there, and I can even make this center of this circle a little larger, and it'll still go through A and B. So for this particular example, if I only have 2 points, I can have many different circles. However, once I introduce this third point in there, letter C, there is only one possible circle that connects through all 3 of these points. And this is not as easy as it seems to find a circle that connects through all 3 points. And once you have that, so now we have the circumference of this circle as we learned in chapter 5. So that's the circum part of this definition here, but it's the center part that we need to figure out. So how do we find the center of a circle? Well, there's a couple of ways of doing that, and the first way is by making a triangle and using angles. So what we have here is we have this diagram. So we have triangle ABC that's found within the circle, and once you connect all the points, you can find perpendicular bisectors of each of these line segments, and the intersection of all of these perpendicular bisectors gives the center O. This is a pretty confusing lesson, but once you know the steps, it's really, really simple. So let's just review first what perpendicular bisector means. So perpendicular bisector. So there's 2 parts to this. Let's just go down here. And let's look at what both of these mean. So first of all, let's look at the word perpendicular. Perpendicular means 90 degrees. So as we can see here, if we have the line segment AB, so I'll just mark this in yellow. If I have this line segment AB, perpendicular means I'm going to create a line that is 90 degrees to line segment AB. Okay, so that's the first part. The second part means bisector. And bisector, this prefix bi means 2. And when something is dissected or bisected in this case, this means cut. So now I am cutting something into 2. So that means I'm going to cut this line AB into 2 equal pieces. So this one here, 1, and this one here, 2. So I'm cutting this line into 2 equal pieces at a 90-degree angle. So there's really only one possible perpendicular bisector, because bisector has to be in the middle at the midpoint, and the perpendicular has to be at 90 degrees. There are many other different types of bisectors that are not at 90 degrees, and there's a lot of other perpendicular lines that are not bisectors, but in order for them to be both perpendicular and a bisector, then you really only have one possible line. And then you do the same with the line segment BC and the line segment AC, and you find all 3 perpendicular bisectors. So that's this purple line here, this purple line here, this purple line here, and the intersection of all of them is the center of the circle. So let's do this in action now. So here's my question. So let's just move the question in. So an equidistant center means we're finding a point, or we're finding the center of 3 points. So we're finding the center, an equidistant center means a point that is the center, and what we mean by center, it means equal distance to a set of points. And geometrically then, the distance from this point, from any of these points to the center, basically is the radius of the circle. So as we looked here, that means B to O, A to O, and C to O are all going to be the same distance. So that's why we call this the center of the circle, and all of these three are the radii. So what we're going to do is we're going to create a circle. Now, unfortunately, you probably don't have a smartboard that's on your page, so you can't just randomly draw circles and change their sizes to find it. So we have to use this method of perpendicular bisectors. So the goal is to find, whoops, that's a circle. So the goal is to find the center of Allen, Kara, and Bryn's houses, because the city wants to place a fire hydrant equidistant, so equal distances from the houses belonging to Allen, Bryn, and Kara, and each centimeter represents 100 meters. How far would this hydrant be from each house? So I'm creating a fire hydrant that would be approximately in the middle, so around here. So to find the center of the three houses. Here's step one. So step one, we need to connect each point. So connect 2 points. So what I'll do is I'll take my line and I'm going to connect A with C. Let me just move this line a little bit here so I make that better. Great. And then what I'll do is I'll find the bisector of it. So now I need to measure with the ruler and find the bisector. So bisector, as we saw, is the halfway point. So let's just turn this around a little bit. Whoops. Where's the little rotation tool on this one? There it is. So I measure on mine, and it might be different from yours on the page, but mine's approximately 5.4 centimeters. So that means the bisector would be at 2.7 because it's halfway. So I'll just mark this in green. So 2.7 is about here. Okay, so that's the first step. Now let me just move this out of the way. Third step now is to measure using the protractor a 90-degree angle to find the perpendicular bisector. So measure a 90-degree segment, which will be the bisector part. So now I have this, my protractor. Let's just move this around. Let's just set this at 90 degrees now. Okay, so let's put on the line at the bisector point, and then we just mark off, and I'll put in green right here. So I just move the protractor away and connect the lines. Okay, let me just change that to a lighter color. And let's make it dashed as well, just so that we can see the line a little bit better. Great, so this is what I have here is the perpendicular bisector of AC between Allen and Kara's house. So let's just mark in a couple of things. So let's just mark in the fact that it is a bisector. So we're going to put these lines to say that they're equal distance, and then I'll be putting in the 90-degree sign to say that that's a perpendicular bisector. Now, I don't really know how far this is going to go, so here's what I'm going to do. I'm going to pause the video, and I'm going to continue the rest. I want you to pause the video as well and make the two other perpendicular bisectors between Allen and Bryn's house and between Bryn and Kara's house so that we can find the intersection of all three. Then we'll check our work together, and we'll find the distance of this fire hydrant to each of the houses. So pause the video right now and we'll continue on right after this. Great. So now we have the actual answers here. So we have the first perpendicular bisector, which we created in green. And then I just continued with the red one. So between Bryn and Kara, I found the midpoint here. I found a 90-degree angle. And so that's the perpendicular bisector. And then I did the same with the blue. I found the midpoint between Alan and Bryn, found the 90-degree angle, dropped it down, and now I've had this intersection here. Now, normally the intersection won't happen so crowded, but in this case, the intersection happens here. So let's just put a little highlighter marking just in there, just so that we can see it. Bloop. Right there. So this is now the location of the fire hydrant. So now what we're going to do is we have to find how far this hydrant is to each house. So what we'll do is I'll take our ruler again and I'll measure the distance from one of the houses. Well, they should all be the same. And in this case, Alan's house is 5.4 centimeters about away. So let's just write this down, that I have the hydrant is 5.3 centimeters. Well, we don't know how much that is in real life because this is a scale drawing. So we'll put that over question mark, or we could put another thing. And then on the right-hand side, we'll put the scale that we know. And we know that each centimeter, it says here, each centimeter represents 100 meters. So in this case, that means centimeters would be on the top because it matches, and 100 meters is on the bottom, or the denominator. Now I can use scale factors or cross multiplication. It's a pretty easy scale factor here, that it's just multiplied by 5.3. So that means my actual hydrant distance is 530 meters. And I could do the same. I could check it with all three distances, and I find that it is 5.3 centimeters from each of the houses. So I know that I'm correct. Great. So just to recap, perpendicular bisector is an important word which connects both the distance and the angle between 2 points. So perpendicular means a 90-degree angle, bisector means cutting those 2 points in half, or finding it at the midpoint. Using 3 perpendicular bisectors, or even 2 perpendicular bisectors, the intersection of at least 2 of the bisectors will give you the center of the circle of all 3 points. And then using a scale, you can find out whether or not the actual distance from these points. So review this lesson, and if we have any questions, we'll go over some practice questions in class. So hopefully you understood this lesson.